You're looking at this right now and you're going, ooh, fractions. I don't like fractions. I know you don't like fractions. The good thing is we never have to deal with those fractions. Because what we're going to learn right now is a quick, easy, one-step method to get rid of every single one of those fractions before you ever have to solve it. Now to do that, we have to go back to elementary and we have to remember something called the LCM, which is known as the least common multiple. So the way we get rid of these fractions is by looking at all of their denominators. If you have one fraction, that's easy. If you have two fractions, you have two denominators. In this example, we have three fractions, so we have 1, 2, 3 denominators. We need to find the least common multiple of all three of those denominators. So the least common multiple of 3, 6, and 4. There's a lot of ways you can do that. The easiest way, the quickest way is to do this. Look at the denominators. Which one is the largest? 6. So if you want to find the LCM super fast, you take the largest denominator, 6, and you find its multiples. What do you mean about multiples? I mean you multiply it by 1. What is 6 times 1? 6. So we know that 6 times 1 is 6, and then we ask ourselves a very simple question. Does 3 go into 6 evenly without a remainder?
Yes.
Does 6 go into 6 evenly without a remainder?
Yes.
Does 4 go into 6 evenly without a remainder?
No.
No. So we have to keep going. That does not work. 3 and 6 go in evenly, but 4 does not. So we find the next multiple of 6. All you're doing is multiplying. 6 times 1, 6 times 2, until you find the least common multiple. So we do 6 times 2. We get 12. And we ask ourselves that same question. All right, does 3 go into 12 evenly with no remainder? Yes. What about 6? Yes. What about 4? Yes. All three of them go in evenly with no remainder, so that means that our LCM is 12. Once you identify the least common multiple, that is your key to unlocking this equation and getting rid of all those fractions using simple multiplication. But you have to find the LCM first. So once again, to find the LCM, you take the largest denominator of however many fractions you have. In this case, we have 3 fractions. The largest denominator was 6, and I find all the multiples. As soon as I find the smallest multiple that all 3 of these numbers can go into evenly with no remainder, that's my LCM. Once we have the LCM, here's how we get rid of all the fractions. We're going to take our least common multiple, and remember that what you do on one side of the line, you must do on the other. So the way we get rid of all these fractions is by multiplying both sides by the LCM. We're going to multiply the left side by 12. We're going to multiply the right side by 12. And when I say multiply, I mean, if we look here on the left side, how many terms are in the parentheses? 2 terms. You have 1/3 x and 5 over 6. So we're going to multiply both of those terms by 12. And here's how you do it quickly. You do 12 times 1. What's 12 times 1? 12. Then what is 12 divided by 3?
6.
What is 12 divided by 3? It's 4. So you get 4, and don't forget to bring down the x. 4, bring down the x. 4x. Okay. So we took care of that one. Then we take care of the next one. What's 12 times 5?
60.
60. 60 divided by 6 is 10. That's a positive sign there, so it becomes plus 10. 2 of those fractions are gone. Next side. So I do 12 times 3. What's 12 times 3?
36.
And what is 36 divided by 4?
9.
So I get 9. I bring down the x. Then the last term, I do 12 times 2. That one's simple. What's 12 times 2?
24.
24. Did I get rid of all the fractions? Yes, I did. And now I just have an equation with variables on both sides. We're not going to solve this. Not yet. Right now, all I care is that you guys know how to find the LCM and simplify. We're going to solve in section 2. Any questions? We're going to do some more examples, though. Any questions here on how we did this? Any questions on how we did this? All of this is practice. Some people clicks right away. Some people it takes 10 examples, 20, 30, 40, 50, 60 until it all clicks. Magically one day you wake up, I get it. His name was Harambe. No, you get it. What's up?
Did you get 9?
Where did I get 9? I did 12 times 3. What's 12 times 3? And then what is 36 divided by 4? 9. That's how I got 9. And I brought down the x. Okay? It's good questions, though. Questions mean we're learning. All right. So we're going to do 2 more of these examples. All we're doing here is finding the LCM and getting rid of the fractions. So here we have 2 fractions. That means two denominators. We don't care about the -8. We don't care about the +4. We care about this denominator, this denominator. And you ask yourself a simple question. Which one's larger? 5. So I'm going to find the multiples of 5. I do 5 times 1. That gives me 5. Does 3 go into 5 evenly? No. So we keep going. 5 times 2 equals 10. Does 3 go into 10 evenly? No. So I keep going. 5 times 3 equals 15. Does 3 go into 15 evenly?
Yes.
What about 5?
Yes.
Yes. So my LCM of 3 and 5 is 15. Once I find that, yes?
Can you just multiply? Like 3 times 5 is 15.
Does that work? Would that work here? 4 times 10 times 5, so your LCM would be 200. You want to find something that works for everything. That works in one specific scenario. Doesn't always work. So I'm teaching you something that works every time. For all problems, for the rest of your mathematical career. All right. So we take this, we wrap both sides in parentheses because we're going to multiply both sides by the LCM, which is 15. And it's the same process, kids. 15 times 2 is what?
30.
And then 30 divided by 3 is?
10.
10, bring down the end. 15 times -8 is what? I'll tell you. It's negative 120. Good. Equals. We do the same thing on the other side. We do 15 times 3 is what? 45. 45 divided by 5 is? 9. 9, bring down the end. Then you do 15 times 4. What is 15 times 4? 60. And we've simplified that. Now I'd be able to go in and solve it. And if I solve that, I would get n is equal to 108. But we're not going to solve it right now. We're going to solve that next, after we finish with later. Okay, one more. Now we have 3 denominators here. So let's go to Marcello. What's your largest denominator? 10. So we take the multiples of 10. 10 times 1 equals 10. Does 4 go into 10 evenly? No. So move on. 10 times 2 equals 20. Does 4 go into 20 evenly?
Yes.
What about 5?
Yes.
What about 10?
Yes.
Yes, so that is my LCM. And I'm going to multiply both sides by the LCM to get rid of all these ugly fractions. 20, and that's a 0 over there. That is some type of 0. There we go. Kind of. All right, so we multiply. Same process. 20 times 3 is? 60 divided by 4 is? 15. So 15, bring down the end. 20 times 7 is?
140.
140. 140 divided by 10 is? 14. Equals. We do the same thing on the other side. 20 times 4 is? 8. 80. Somebody said 8. 80 divided by 5 is? 16. Don't forget the end. If you forget the end, everything else you have at this point will be 100% wrong. And then last but not least, 20 times 15 is? 300. And that's it. Just simplify. Get rid of them. One step at a time. Any questions on this? Any questions? All right. And move on. So we still have to get rid of the fractions first. So same process. We have 5 and 10. Which one's larger? 10. So we need to find the LCM, and we're going to find the multiples of 10. 10 times 1 is 10. This one's pretty easy. Does 5 go into 10?
Yes.
Does 10 go into 10?
Yes.
So that one was pretty easy. So we multiply both sides of this by 10. Make sure you multiply every term in the parentheses. Don't forget the variables. 10 times 3 is 30. 10 times 4 is 40. 40 divided by 5 is 8. So plus 8b equals. On this side, 10 times 9 is 90. 90 divided by 10 is 9. Don't forget the b. Now that we have the fractions eliminated, we can solve this. And guess what? This is just a one-step equation to solve. Watch. So, Here's what I want you guys to understand. When you have variables on both sides, you once again look at the coefficients. Which one's smaller? 8. So we need to move this over here. What's the inverse of a positive 8b? Negative 8b. So we're going to subtract 8b here. We're going to subtract 8b here. And then we always work from left to right. We bring down the 30. What happens to the 8b's? They cancel. And then 9 minus 8 is 1. And 1b is the same as just writing b. And that is solved. Just like that. It looked complicated up here with all this craziness. But once you got rid of the fractions, it was one step to solve. That was it. Boom, boom, bang, bang. Yes.
So, because 9 minus 8 is 1, you have to put the 1. So
You don't have to put the 1, so it's just b. You've solved it. As long as it's a positive 1, you're done. Positive 1, you're done. Okay.
Doesn't right.
Let's try another one. All right, let's try this one here. So this one, by the way, I want to point this out. I chose this example for a reason. We don't care that there's a negative there. We don't. It doesn't mean anything to us. All I care about right now is the denominators. My denominators are 6, 2, and 4. Which one's larger? 6. So we're going to find the multiples of 6. 6 times 1 equals 6. Does 2 go into 6? Does 4 go into 6? No, not evenly. So we go to the next one. 6 times 2 equals 12. Does 2 go into 12? What about 4?
Yes.
And we know that 6 does. So that's my LCM. So I'm going to take the LCM and multiply both sides by 12. And this is where you got to be careful. If you multiply wrong here, everything else you do after this point will be 100% wrong. So, little arrows help me remember that I've multiplied. So I do a little arrow. 12 times 5 is? 60. 60 divided by 6 is? 10. Don't forget the y. That one's done. 12 times 1 is? 12. And don't forget that's positive, so plus 12. Equals. I do the same exact thing on the other side. 12, and ignore the negative for now. We'll come back to it in a second. 12 times 1 is? 12 divided by 2 is? 6. Now, bring down the negative, bring down the y. 12 times 1 is? 12 divided by 4 is? 3. And we've gotten rid of all of the fractions. And this is what you have to remember how to solve equations with variables on both sides. We look, there's no terms for me to combine. Variable term, constant, variable term, constant. Okay. But I have to get all the variables on one side of the equation. To do that, I look at my coefficients. Which coefficient is smaller, class? Negative 6. So we need to move this here. What is the opposite or the inverse of a negative 6y? Positive 6y. So we add 6y, we add 6y, and we work from left to right. 10 plus 6 gives me 16y. I bring down the positive 12. I bring down the equal sign. These will cancel. I bring down the 3. Looking at it right now, I can already tell my answer is going to be a fraction. I'm totally okay with that. Right now, we still have work to do before we can divide. I cannot divide yet because I have a constant here. I have to get rid of this constant and have this variable term all alone before I can divide out that coefficient. So I do the inverse. What's the inverse of a positive 12?
Negative 12.
So I subtract 12. I subtract 12. Next line, work from left to right. You bring down the 16y. Those will cancel. Equals 3 minus 12 is negative 9. Now that you're here, now is when you divide. When you have a variable term with a coefficient on one side by itself, you have a constant on the other side by itself, this is when you divide out that coefficient. So we're going to divide both sides by the coefficient. Mr. West, what's the coefficient? It's the number next to the variable. 16. So we divide both sides by the coefficient. 16 and 16. That's a 6, by the way. Those will cancel, leaving you with y is equal to negative 9/16. You cannot simplify that fraction, so we leave it alone, and that is my answer. All right. Let's try these. The thing is, these are easy. Decimals, you treat them the exact same way. All right. Alright, so decimals now. The good thing is, you treat these the exact same way you would treat any other type of coefficient out there. Once again, the goal is to get the variable terms on one side, constants on the other. So we still look at the coefficients, guys. Which of my two coefficients is smaller here? 1.6. So we're going to move this over to this side. Variables on one side, constants on the other. What's the opposite of a positive 1.6w? Negative. So we subtract 1.6w from both sides. When I do that, 3.6 minus 1.6 gives me, anybody? 2. So I have 2w is equal to, these cancel, 24. When I get to that point, I think everybody in this room knows what to do. You're dividing both sides by the, what is it? It starts with a C. The coefficient. And what is your coefficient here? 2. So I divide both sides by 2. And I get W equals 12. There's no fancy tricks here. The good thing is you have the aid of a TI-30XA, brought to you in part by our friends at Texas Instruments. Keep on working strong, people. And that will help you add or subtract the decimals. Any questions on the first one? We got 2 more. What's up? 3.6 calculator. What's 3.6 minus 1.6? Punch it in. What do you get? 3.6 minus 1.6 is 2. We're just subtracting decimals. That's it. Let's try another one here. So here, variable term constant, variable term constant. Same process though, as any other equation with variables on both sides. Melody, which coefficient is smaller? Negative 2.6. So we're going to move that over here. What's the inverse of a negative 2.6? Positive. So we add 2.6x to both sides. And you work from left to right. 3.4 plus 2.6 gives me 6. I have 6x. I bring down the negative 17 equals, that will cancel, positive 43. Oh, negative 17. Good catch. You roll away. Negative 17. There we go. Okay, so now that we're here, we add 17 to both sides. Why do I add 17 to both sides, people?
That's your lowest coefficient.
No, that has nothing to do with this. This is a coefficient. This is a constant.
You have to leave it.
Why do I add 17 to both sides? Tell me why.
You have to get the
Because I have to get the variable on one side and the constant on the other. I must isolate this variable term. So by adding 17, I'm removing this constant from the left side of the equation. I bring down the 6x, those will cancel, equals 43 plus 17 gives me 60. And then everybody in this room knows what to do. You divide both sides by the 6, which is the, what's the proper name? Coefficient. I divide both sides by 6, and I get x equals 10. Baby. All right, next one. Once again, we look at the coefficients. So, Amber, which coefficient is smaller?
2.25.
2.25. When you do this, be careful. Use your calculators to make sure that you're adding or subtracting these correctly. So the inverse of positive 225 is negative 0.225. We're going to subtract this from both sides. And you have to be careful when you do that to make sure that you get the right difference. Those cancel. I bring down the 5. 13.5 minus 2.25 gives me 11.25. Don't forget the t. Plus 14. Now that I've done that, I have all my variables on one side. I must get the constants on the other side. To do that, I got to get rid of this positive 14. So I subtract 14 from both sides, and I get negative 9 is equal to 11.25 t. And it's still the same process. We still have to get rid of the coefficient. So there's multiplication happening between 11.25 and the t. What's the opposite of multiplication? Division. So we're going to divide both sides of this equation by 11.25. 11.25. That will cancel. Then you need t. Over here, guys, what's 9 divided by 11.25? 0.8, right?
Yeah.
So we got 0.8. If you do this correctly, 9 divided by 11.25 equals 0.8, but don't forget that's a negative, so it becomes negative 0.8. That is what t equals. Remember, this goes into your calculator first, 9 divided by 11.25. Don't forget that's negative. Any questions on this? No? All right. So the distributive property, nothing special here. The good thing is you've already done this. You have. What do you mean we've already done this? Have you or have you not had something sitting out the parentheses, outside of the parentheses already, and then multiplied by stuff inside the parentheses? Yes or no?
Yes.
Yes, you have. That's all the distributive property is. So you're going to ask yourself, what's happening between the 3 and the parentheses? What operation's happening here? Multiplication. So all you're going to be doing is multiplication. You're multiplying and then you're solving the equation. So what is 3 times x, class? 3x. Be very careful when you do this. Don't forget a term. These little arrows help. That's how I do it. That's how I've done it for years. 3 times x is 3x. 3 times negative 5 is negative 15. Bring down the positive 1. Bring down the 2 plus. I'll write in my invisible 1 here so this is easier for me to solve. Now that I'm doing this, this goes back to the last lesson. I have an equation with variable on both sides. Are there any like terms that I can combine? Yes or no?
Yes.
Yes, on which side? On the left side. I can combine these two constants, negative 15, positive 1. When I combine those, I'll end up with 3x minus 14 is equal to 2 plus 1x. Once I'm here, one variable, one constant, one variable, one constant. This is where I look at the coefficients. Which coefficient is smaller, class?
1x.
The 1x. So I must move this over here. What's the opposite of a positive 1x?
Negative.
So subtract 1x from both sides, and I will get 2x minus 14 is equal to 2. So I got all the variables on the left side. I must move all the constants to the right side. What's the opposite of a negative 14? Positive 14. So we add 14 to both sides, and we'll get 2x. These cancel. That equals 16. And I think everybody in this room knows what to do at this point, yes or no?
Yes.
You divide both sides by the coefficient. The coefficient is 2, not 2x, 2. 2x equals 8. So distributions, not really a whole lot of new stuff. Just one new thing. That's it. Questions on this one? No. Have another example, don't worry. Now here we just have distribution on one side. Eventually we'll have distribution on both sides. Same process though. So here, distribution. Let's go to Camila. We're going to distribute here. We always have to distribute first. So I'm going to distribute the 2 to the 2x and the 2 to the 2. What's 2 times 2x?
4x.
4x. What's 2 times 2? 4. Bring down the 1. Bring everything else down. And then you need to go through and be very careful and realize that there's things on both sides that you can combine. On the left side, Andrea, on the left side, what 2 terms can I combine?
4 and 1.
Positive 4 and the positive 1. Daniele, on the right side, what 2 terms can I combine?
2 and negative.
2 and negative 3. So when I do all this combining, I'll combine these 2 right here. That's going to give me 4x plus 5. And on the other side, I combine the 2 with the negative 3. That is going to give me 2x minus 1. And we're at the same process now. I have variable term constant, variable term constant. So I must get all the variables on one side, all the constants on the other side. Look at the coefficients. Ms. Cardenas, which coefficient is smaller?
2.
The 2. So I must move this term to this side. What's the opposite of a positive 2x, class?
Negative 2x.
Negative 2x. So I subtract 2x from both sides, and I will get 2x plus 5 is equal to, that cancels, minus 1. So I got all the variables on the left side. I got to get rid of that constant. So I can divide out my coefficient. What's the opposite of a positive 5?
Negative 5.
So I subtract 5, and I get 2x is equal to negative 6. Everybody in this room knows what to do now. What do you do?
Divided by 2.
Divide both sides by 2 to get rid of that coefficient. X equals negative 3. Good. The only difference now is that we have distribution on both sides. The good thing is you've already done that. We've multiplied both sides before by the LCM to get rid of fractions. But it's the same thing, just be careful. Make sure that when you distribute, you're distributing it to every term. Use the arrows to help you. 3 times x, 3 times negative 13, negative 8 times 9, negative 8 times x. Make sure you multiply every term. That is key. So we have 3 times x, that gives me 3x. 3 times, open the door, 3 times negative 13 is negative 39. Negative 8 times 9 is negative 72. Negative 8 times x is negative 8x. We distributed. We got rid of all those parentheses. And now we're at the same point. Who can tell me what to do next? Marcello, what do you do?
You find the lower,
Lower, smaller coefficient. Which coefficient is smaller?
negative 8.
The negative 8x is smaller, so we're moving the negative 8x over here. So I add 8x to both sides. I get 11x. I bring this down, minus 39 equals negative 72. Now that all my variables are on one side, I must get my constants on the other side. Ms. Guerrero, what do I do now? I need to get this alone, so I have to get rid of this. What's the opposite of negative 39? Good. So I add 39. Perfect. And I will get 11x is equal to negative 33. What do we do now, class? Divide both sides by what?
11.
11. And we get x is equal to negative 3. So distribution on both sides always takes us back to the same point where we have an equation with variables on both sides. And it's the same process over and over and over. Move the coefficient that's smaller first, get rid of the constant, and solve it out from there. Any questions on this one? No questions? One more to go. Little problem. I got a fraction. You know I don't like fractions. I don't. So the thing is here, and this is where I need your utmost attention. Same process here, I have to get rid of that fraction. The good thing is I only have one denominator. What is that denominator?
4.
So what's the LCM of 4?
4.
4. So what we're going to do is we're going to multiply both sides by 4, but here's why I need your attention. When we already have parentheses, we don't use additional parentheses. We use these little brackets like this, and there's a reason for this. So bracket, bracket, multiply by 4. Bracket, bracket, multiply by 4. Do that, and I'm going to tell you why we do those brackets. Look up when you've done it. Okay. So there's a reason we do those brackets. You see how we have parentheses in here? So when I distribute this 4, I'm only distributing this 4 to what term? To the 3/4, to what's outside those parentheses. So I only distribute it here. And here I only distribute the 4 to the
Negative
2. I don't distribute it to the stuff inside the parentheses, only on the outside. So here, 4 times 3 is, 12 divided by 4 is 3. So 3, I bring down the x minus 13. Equals 4 times negative 2 is negative 8. I bring down the 9 plus x. I've gotten rid of the fraction. I like it. Because now I know what I'm doing. I'm distributing once again. On the left side, Yusuf, what do I distribute on the left side?
3x.
I distribute the 3 to the x and a 3 to the negative 13. So I have 3x minus 39 equals, starting to look familiar. What do I do on the right side? Nicolette, what do I do on the right side? Okay, so tell me, what do I do?
You do negative 8, like you multiply it.
Negative 8 times 9 and negative 8 times what?
Times x, that's 1.
And I get negative 72
Times
minus
yeah.
8x. Huh, that looks familiar. Looks real familiar, doesn't it? Didn't we just
We just did that.
Go back.
do that one right here?
Go.
Oh, we did. So we just did that one. Now that we've done this, let's see if we remember what we did a second ago. What's the smaller coefficient, class?
Negative 8.
Negative 8. So we add 8x to both sides, and you get 11x minus 39 equals negative 72. You add 39 to both sides. You already know where this is going. Equals negative 33. Divide both sides by 11. You get x equals negative 3.